Hey guys, Mr. B here again, bringing you another math video, calculus video that is. And this video is on limits at infinity. I'm trying to read my own writing here, I can't even read it. Limits at infinity for rational functions. So what chance do you have, I guess, eh? So good luck, best of luck to you. This is not only a calculus video, but it's also a video where you have to interpret someone's handwriting. So guys, I've been making a lot of these videos, so if you like this video, you can go ahead and share it, or you can keep it completely secret so that all your classmates do worse than you do. I don't know, it's up to you. But yeah, if you like it, share it. You know, give me a Facebook share. I want to be Facebook famous, not really, but yeah, if you like it, just give me a like, you can leave me a comment, do something, interact with me. I'm bored. So limits at infinity are completely different than limits to a finite number like 0, like we've been doing. So they're different because they actually have a different meaning. Limits at infinity actually mean that you're finding the horizontal asymptote. I'm not going to spell the word because I don't want to mess up the spelling. Horizontal asymptote. So it's basically what happens to the function is x is really, really big or really, really small. So for rational functions, they approach, well, you know, some of them approach a number. So they go towards a number. And that's what we want to find when we're doing this stuff. What happens to is x is really, really big or really, really small. So we're doing plus infinity for this one, so we're thinking really, really big. So the technique we do for that is dividing by the highest power in the denominator. So this works for every single type. Not only rational functions, but radical functions that I'll do another video on shortly. So if you're looking for radical, which is, you know, I can immediately tell right now what the horizontal asymptote is. I'm going to teach you that cheat, but I want to go through the process with you just so you see it. So when you get a more complex function, then you're not like, oh my God, where did this come from, right? So it works with every single one. This is the technique you use. That's what I love about calculus. It's like there's a technique, you just need to know the technique. It works with a bunch of stuff. So the highest power in the denominator is x cubed. So I'm dividing every single thing by x cubed. So your calculus teacher might be a mean person. It's entirely possible because math teachers, there seems to be a higher proportion of mean math teachers than any other teacher. And he might say you have to use this technique all the time, whereas I say if you can look and tell, you do it. Like why would we waste time trying to work out something that we can just look and tell? But anyway, I'm showing you the technique, so you don't need to cry about it. So we've reduced down what we can. So x cubed divided by x cubed. So x cubes are gone. My x cubes here, so that leaves 1. That leaves 5 up there, and then I got the squared gone with the on top, and then I got just an x left, and then this guy just stays the same. So, I'll just rewrite this. So I have 5 minus 1 over x cubed, all divided by 1 plus 3 over x minus 6 over x cubed. So anytime we have just an x left in the bottom, I mean, think about 1 divided by something huge, like a kabillion. So 1, 0, 0, 0, 0, 0, 0, 0, 0, something huge, massive. And it's going to be like close to 0, right? So essentially, and I did it again. I forgot my infinity sign. I'm so used to writing 0. I just did a bunch of trig limit videos. Anyway, so think of this being infinity, and some people actually write this. I never write this, but I'll show you anyway. You know, 1 over infinity, and I'm not putting infinity cubed. That doesn't make any sense to me. So 1 over infinity minus 1 over infinity, or 6 over infinity. So essentially what you have is 5 minus 0 over 1 plus 0 minus 0. So these all things are really, really close to 0, so essentially that's what they are. And then you end up with 5, right? So here's the cheat method. If you have powers that are the same, so I get an x cubed and x cubed, so those are the highest power, and the top and the bottom are the same, then you can find the limit of this by just simply dividing the coefficients. 5 divided by 1 is 5. So it works for any single function. Let me make another one. So if I say there was 10x cubed minus x plus 1 divided by 20x cubed plus 5 minus 10, then my horizontal asymptote, or my limit, would just be 10 divided by 20. 10 divided by 20, which would be a half. That would be my horizontal asymptote. And that's it, guys. That's literally it. Like, there's nothing more to it than that. When you have the power, as long as the powers are the same, the highest powers are the same, so you match them up, right? All right, let's try another type. So, this guy right here. So you notice immediately the powers are not the same. I've got a squared on top and a cube on the bottom. So I'm going to use my technique, and I have negative infinity this time. Makes no difference, guys, for this stuff. It doesn't change anything. Negative infinity is just basically you got to write an extra negative sign there. That's the only thing that you got to worry about when you're doing rational functions. Now, when you're doing radical functions, completely different story. So I'm going to divide by the highest power, which is x cubed. So we're x cubed. All divided by 2x cubed. So on the top here, I get the limit. 6 going to infinity, so I get left with the squared cancels, the cube is gone, so I get 4 over x. The x is gone, and this is changed down to a squared, so I get 1 over x squared. And then on the bottom I get left with 2. So essentially we got x's on the bottom, so 4 over negative infinity, 0, 0 over 2. So essentially I get 0 over 2, which is 0. And there it is. So the next rule for limits of rational functions as it goes to infinity, if the highest power in the bottom, the limit is always 0. Highest power on the bottom, limit is always 0. So we got a squared on top, a cube on the bottom, therefore the highest is in the bottom, limit is 0. Alright, let's try the last type, so you might be able to guess where this is going. So in this particular scenario, I have the highest value power on the top, which is a 4. So I still divide by the highest power in the denominator, which is x cubed. So the limit as x goes to negative infinity. So divide everything by x cubed. So x to the 4 divided by x cubed minus 2x over x cubed plus 1 over x cubed. All divided by 5x cubed over x cubed plus 7x squared over x cubed minus 3 over x cubed. So I cancel the x to the 3, and then this gets turned into just an x. X canceled, left with a squared. That one doesn't change. Those are completely gone, left with just 5. This one's gone, I'm left with just an x on the bottom. That one doesn't change. So you can see the problem here is that I'm left with a variable in the numerator. So it's not over that x. So really what I have here is 5 times infinity. So really that's infinity minus 0 plus 0 all over 5 plus 0 minus 0. So I get infinity over 5, which is infinity. So the rule is for rational functions, highest power on the top, there is no limit at infinity. So there's no horizontal asymptote. Highest power on the top, no horizontal asymptotes. So let me just summarize that piece of information. So the first one is same powers in the top and bottom. So we divide coefficients of the highest powers. So if you got the same high power in the top and the same high power in the bottom, you just divide the coefficients, you get the limit at infinity. The second one is highest power on bottom. So the highest power is on the bottom in the denominator. The limit is 0. Y is equal to 0. The third is highest power on top. Then the limit does not exist. There is no limit. There's no horizontal asymptotes. There's nothing to worry about. That is indeed highest there, if you can't tell. Alright, let's do one more. I'm going to do this one just by looking. No more to it than that. Alright, so this one's a little bit trickier because everything is not ordered in, nice descending powers. So if I look, the highest power on the bottom is power 5. The highest power on the top is power 5. So same on top and bottom. That tells me that there is a limit, and it's when I divide the coefficients. So the coefficient of the highest power here is -2. On the bottom is -4. So that just becomes 1 over 2. So that is a great cheat to remember, guys, especially if you're doing curve sketching and you don't want to go ahead and write all those steps out because you got a big old problem to do. So hopefully this video helps you guys, and thanks for watching, and I'll see you guys in class.